Okay, let's look at the homework 7.9-8.1, problem number 1. All right, so we want to evaluate this double integral over the region, which is a semicircle bounded by those guys. All right, so let's do that. All right, so if you have, let's say, a region, so we need to probably sketch the region. So the region is going to look like this. All right, here's the x, and here's the y-axis. All right, and this is a semicircle with radius 4, because the square root of 16 is 4. So it's going to go through here, 4, and here, -4. Right, and up here, so +4 there. Right, so then it's a semicircle, so it's gonna look kind of like that. Right, oops, sorry, that doesn't look very nice, but you get the point. So this is the region. All right, so we can set up the integral. So it's going to be a double integral, right, of x. All right, I'm going to probably do with respect to y first, then with respect to x. All right, so we're going to fix x. All right, say x is here. All right, then you look at the line segment and determine where this line segment starts and ends. All right, so this line segment starts on the x-axis, which means that the y value is 0 there, and ends on the semicircle. So we have an equation for that. Y equals square root of 16 minus x squared. Right? So which means that the lower limit here, so y equals 0, and the upper limit is y equals square root of 16 minus x squared. Right? Then you can see that, so this is going to be an entire semicircle. So this line segment has to start from -4, then keep on increasing the x value. And in order to cover the entire semicircle, you're going to have to go all the way to +4. So x equals -4 to x equals +4. Right? So x equals, oops, maybe I should use blue there. So x goes from -4 and goes all the way up to +4. All right, so let's evaluate that. All right, so this is going to be, all right, first thing we can do is actually, here, this is antiderivative with respect to y. So this is considered to be a constant. So we can actually put it outside of the integral. All right, so let's do that. So it's an integral from -4 to +4. Right? Then x is outside. Right? Then you have an integral of just a dy from y goes from 0 to y goes to equal to 16 minus x squared. Right? dx. Right, then antiderivative 1 is just y, since we're taking the antiderivative with respect to y. So you would have y, then you have to go from 0 to square root of 16 minus x squared with respect to x. All right, so you plug in square root of 16 minus x squared minus 0. So you would get this guy. All right, then you have x square root of 16 minus x squared. dx. All right, and you can use substitution to evaluate it in a normal way, but the trick is, the slickest trick would be if you can see that this is an odd function, right? So this is actually an odd function. If you're going from -4 to 4, odd function is symmetric about the origin. So if you go from -a to +a, the integral is going to be 0, right? So we didn't have to do much calculation to compute that. So it's actually 0. All right, let's check to see if it's correct. All right, the answer we got is 0. 0 is the right answer, so 0. You can kind of see that from there, but we'll go ahead and submit for testing. All right, so it looks like we got this one correctly. All right, that's it. I hope that this was clear.